Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Second question, longest square streak in an array. So let us first read this question, constraint, example, and finally coding part for the same. So here you are given an integer array num. A sequence of nums is called square streak if the length of the subsequence is at least 2. After sorting the subsequence, each element except the first element is square of the previous number. So that is the thing. Now return the length of the longest square streak in nums or return -1 if no square streak is there. So basically we are required to figure out with that subsequence where the first element which is there, that is normal, it is there. But other elements which are there, those should be square of the previous element. So the thing is that after we sort that particular subsequence, it should be something like this. Let's say we take 2, the square of 2, that is 4. Then 4 square, that is 16. Then 16 square, 256. So like this only the sequence should be there. So this type of subsequence length we are required to return. So that's the thing which we are required to do in this particular question. Now let us see the constraint. So constraint at n is per 5, so we can only go up to n log n solution at max. Means order of n solution at max, order of n or log n solution. This is what we can go ahead with. And each element is up to 10 raised to the power 5. So when we will be doing square of this 10 raised to the power 5, then it will be becoming 10 raised to the power 10, right? So that's why the data type we are required to use is long into suffice in the same. So now let us first see the examples which are being given to us. So here this is given to us. Now answer is 3. How it is 3? They have take after we sort this particular, right, 2, 3, 4, 6, 8, 16, right? So we take for 2. Then square is 4. Then square is basically 16. Okay. Right? Then if we check for 3, so 3 square is not present. Then we check for 4. 4 square is present, that is 16. But till now, the longest length was 3. So 2 won't be accepted, 3 is there. Then we go for 6. 6 square is not there, right? Then go for 8. 8 square is not there. So final answer is 3. So this is how we are required to check for each and every element and then directly go with the answer. So that is the same. Now let us go ahead for the implementation part for the same. So here, first we are sorting all the elements so that we can easily check that which element we are required to check or not. Then after sorting, getting this set, this we can even take another step. Let me check if we can take it or not. Yeah, rather than set, we can use another set as well because at the starting only we have already sorted, so nothing concern is not there. Then using this another set, we are first inserting whatever we have stored in our whatever is being stored in our this particular E, right? That we are storing in the set. Now, for checking for the maximum, now, now we will be going ahead for this first we will be traversing this particular and we are required to check that because we are required to make the thing is that we will be making square and storing them and then checking that if that exists there or not. That is how we will be going ahead. So here, this is for the maximum length, cutting this map, and then length is here. Now we will be going ahead by making whatever x we will be having at that moment. We will be squaring that up, and whatever square is there, that we will be checking in as this set. Here set we have just taken for doing a lookup that does that particular element exist in our input or not. So that's the thing. Now, if that exists, then we will be increasing the length, else we will be breaking out from this particular while loop. If things goes all right, and if uh, then we can also then one more thing is that when we will be doing the square, right? That moment there could be some scenario where doing the square can make it reach the of limit means basically means if 16 is the highest limit. When doing the 16 square, it will be 256, right? That would be done at this moment. And then we will be, if we will be checking here, then it won't be there. You can go to this break as well. But then in some scenarios, we are also required to check that if it is greater than this particular, then surely we are required to break so that it doesn't go ahead with this situation. Means if 16 exists, right? So 16 would be here only and length would be increased, and then at that moment it won't go to this break. But if at some moment, say if this 256 is already there in that particular, and not 256, just check, because here you can see that it is 4 digits, right? And at max it can go to 10 raised to power 5. So at any moment, if X is there, which is not in the range of our input, right? And it becomes because of this only, then at that moment only we will be breaking out from the same so that we can avoid that runtime audit. So that's the whole scenario. Now, after this particular while loop, we will be getting our length that we will be directly comparing and updating our mx variable here. If our mx is equal to 0, because here we were starting from -1, right? And if there is no subsequence existing where squares are present, right? Only one single element we have figured out till now. Then at that moment our mx will become equal to 0. Then at that moment we will returning -1. Else we will be returning mx plus 1. Because we are having the length of a subsequence, but we have not added 1 for that starting element. So that's why we will be adding 1 here. And that's how we are required to do this particular question. Now comes the part for the time complexity and space complexity for the same. So time complexity of this question is, here we can see it is order of n this while loop which is there, and even this sorting part which is there. So because of all of this, our time complexity becomes order of n log n, and the space complexity is order of n because we are using this unordered set. So yeah, this was all for this particular question. If you have any doubt, you could comment that down. And time complexity, I've always known. Yeah. And one more informational thing. As you're already doing this Leetcode bi-weekly, weekly challenges, you can also try the Newton School Coding Contest about which you can figure out about all the details in the description below. There is one link you can click and get all the details for the same. So if you would be in the top performer for the same, you will be getting some exciting prizes. About that also you can figure out in that link only. So yeah, this was all for today's video. So, thank you.